Hello, my name is Shelly Moore. I'm a research scientist here in Southern California, and I study trash. I love showing this picture of a tree that I took in a local riverbed, and it just goes to show you how much trash is out there in our environment and how it's impacting our environment. There really is no time to waste when we're looking at trash issues and how it's impacting organisms and humans as well. Let me tell you a little bit about myself. I was born and raised in Southern California. I got my bachelor's and master's degree at California State University, Long Beach. I studied fish. I was a marine biology major studying fish, and I got interested in trash because while I was in college, I worked as a sweeper at Disneyland. And I got to see a lot of littering accidentally, on purpose, and really became interested in looking at litter patterns amongst people, and how eventually that litter gets into the environment and starts impacting organisms such as fish. So I've been studying trash for a long time. It started in 1994, was the first study I participated in, and I've been doing it ever since. I still get to do fish projects, but most of my focus is on trash. I'm an adjunct professor at Santa Ana College teaching environmental science. I also serve on the board of directors for the Southern California Academy of Science. Most recently, co-founded the Moore Institute for Plastic Pollution Research with a gentleman by the name of Charles Moore. He is often credited with discovering the Great Pacific Garbage Patch. The Great Pacific Garbage Patch is also known as the North Pacific Central Gyre. This was a study that we worked on almost 25 years ago. It actually started because Charles was sailing his boat from Hawaii to California, and he came across this area in the middle of nowhere where he was seeing tons of trash, in particular plastic. He wanted to do a study to document how much he was seeing, so we helped him develop the study, and we found that there was essentially, for every 6 pounds of trash or plastic that was found out there, there was only 1 pound of plankton that was found. So there's a pretty high ratio of plastic to plankton. In this study has been cited by many scientists and was really the start of people realizing what a problem this issue could be, particularly in areas where there are no humans. I love showing this picture. This goes to show how larger pieces of plastic break into smaller pieces. So on the left you see a toothpaste tube, a cap to a water bottle, and those things are breaking up and becoming those smaller plastic items on the other side of the picture. It's a really big problem. You could have one thing that's one piece of trash all of a sudden become thousands of pieces of trash. How does this type of stuff get out there? Don't we put everything in landfills? Well, not everything goes to a landfill. There's some people that purposely put plastic items in the environment, and again, accidentally may put it as well. Once it gets in the environment, there's a number of pathways it can take to get to the ocean. Through stormwater, whenever we have a big rainstorm, we have highly impervious substrate here in Southern California. What does that mean? Basically, that means we have a lot of concrete, a lot of asphalt. And because of that, water flows off the land quicker than it would if we hadn't had more natural vegetated areas. So those microplastics and larger plastic items get down into the ocean via stormwater pretty readily. Wastewater also contributes, particularly microfibers from when you're washing your clothes, and then atmospheric deposition. I was at a meeting in Denver a couple years ago, and we took a field trip to visit an air sampling station, and they were telling us that they've started to see microplastics not just in the city, their sampling station in the city, but also their sampling stations in some pretty remote areas of the Rocky Mountains. Rivers are a big pathway for microplastics down into the ocean, and also some of the aquatic activities that we have going on offshore contribute as well. Fishing line is a big thing that we find. Nets, pieces of nets that have been lost out at sea are a big thing that we find out in the ocean as well. So those are some of the pathways. How does it impact humans? Well, they've been finding microplastics in a whole bunch of different things recently. Tap water beer. They've been finding microplastics in shellfish, all kinds of things that we are exposed to, whether we drink or eat them, as well as breathing in air. And most recently, there's been another study that's come out that says they're finding microplastics in human placentas, meaning that the mothers can potentially be passing microplastics on to the fetuses during the gestation period. So there's a lot of concern. We don't know specifically what the impacts on humans are directly. There's a lot of research that's currently being done to look at that. Am I hopeful? I am absolutely hopeful that we can actually do something about this project, or this problem, I should say, of plastic pollution. If we continue doing what we're doing today, plastic pollution will continue to basically go up at a pretty high rate. But if we make even small changes to what we're doing and reduce the plastics, we can make huge differences. And in California, lots of legislation is being written and going through the proper channels. Hopefully some of it will be passed so we can reduce our input of plastic pollution into different environments. And I'm hopeful that we will get it done. What am I specifically doing here at the Moore Institute? Well, we as a group are doing a lot of things, and one of them is participating in an international intercalibration study. You'd be surprised. You'd think that the methods for studying microplastics are pretty easy, but they're not. Every lab is doing something a little bit different. So this was a great attempt at standardizing those methods and informing the state of California on these methods so they can actually use them in meeting their legislative requirements for looking at microplastics in drinking water. You can see an example of some microplastics here on the left. You've got a fragment, the green sphere, and a microfiber. We've got a lot of high-end equipment here at our lab, and we can do a lot with it. The equipment on the left here, the microscope on the left, where you see the two people working on, that's a really high-end piece of equipment that actually is used in a lot of forensics work to analyze samples that come in from crime scenes. We use it to look at plastics to determine what polymers are making up those plastics. So it's a really cool machine and can do a ton of things. This is the data that comes out of that machine, these graphs, and what we do is we take those graphs and match them to known libraries, and we can discover what polymers make up that plastic by doing that. I'm going to end by sharing some information with you on our social media. Please follow us. We also have a website. You can take a look at that. And if you have any questions whatsoever, please feel free to give me a shout out and ask me questions. Thank you for the opportunity to talk to you, and thank you for listening. I appreciate it.